So this is Suganthy, Associate Professor from Department of VC, Wheeltech Multitech Engineering College. Today, I would like to take the session on topic on subnet mask. Before getting into this topic, I want to say about IP address. What is IP address? This is nothing but identifier, unique identifier for the device on a computer or device on a network. The device can be your system or computer. Let me start with the topic of IPv4 addressing. The IPv4 consists of 32-bit address, which is given in the example. The address of IP address is given here, 192.168.0.1. Each of this one is the octet, which is given as octet bit representation. That is 8-bit representation. 192 is given as in binary form as 8-bit representation. Also the 168 is given as the 8-bit representation. 0 is also given as 8-bit representation. And 1 is 8-bit representation. So combining these two, the IP address space is 32-bit address. The IP address consists of two parts. One is network portion, other one is host portion. So this is the IP address. This is the example shown here. All the devices have this own IP address. They are connected together. This is the network. So let me see what is subnet mask. I am coming to the topic now. What is subnet mask? By seeing the subnet mask, we'll understand how many number of bits of an IP address can be assigned for a network portion. So let us see the thing. The binary representation of an IP address is given below in the example. For 192, that is 11, 6 zeros are there in the example given here. Likewise for 168, 10, 10, 10, 00, 1 is 7 zeros continuously, then last one is 1, 0 is 8 zeros. So 8, so it's an acted representation, binary representation. So 4 8s are 32. So IP address is 32-bit address. So 192, how it's come 11, 6 zeros? We know the thing. That is 8421, then before that 16, then 32, 64, 128. So what are the numbers to be added to give 192? 128 plus 64 will give you 192. That's why the binary representation of 192 will come 11, 6 zeros. So similarly for 168, 1 and 0 will find the binary representation of an address. Now we'll see the subnet mask for the thing. So 192.168.1.0. The subnet mask will be, what are the number will be given for the network, IP address. The same thing, we have the thing that is 255, 255, 255. The last one is 00. So 8 ones first, then 8 ones, 8 ones. So 3 8s are 24. So 24 bits are allocated for network portion and 8 bits for host portion. The 255, 255, 255 all ones denote the network portion. So how will you find them? How will you find them? Network ID from the given IP address and the subnet mask. Let me say the thing later. See here the subnet mask. First one is the net IP address. So subnet mask 8 bits are there. So 24 bits for network portion, 8 bit for host portion. Next one, if you have instead of 255, okay, the next, this is the next example. Next example, which consists of 172.16.1.0. The subnet mask is 255.255. That means 255 first portion, then second portion 255. So the 8-bit portion, the octet portion can take the values from 0 to 255. So all are 1 means it takes the value of 255. So two portions of the octet has the value of 255. So only 8-bit plus 8-bit 16. So 16 bits are allocated for network and another 16 bits are allocated for host. In the next example, only 8 bits are allocated for host and 24 bits for host, 8 bits for network. 8 bits for network and 24 bits for host. So from the subnet mask, what you infer means how many number of bits of an IP address can be allocated for the network address. So 255 means only the 8 bits are allocated for IP address, remaining are treated as host portion. So instead of 255, if we have a number like 224 means what you will do? What are the bits are allocated for network and what are the bits are allocated for host? So 255 mean 8 bits. The next also 255, 8 bits. So 8 plus 8, 16 bits. Remaining next one is 224. How will you allocate the network portion means you have to find out the binary equivalent of the 224. I already explained. So 229, the last MSB is 128. The other one is 128 plus 64. 128 plus 64, then 32 will give you 224. 192, then 32 will give you 224. So the first MSB bits are given as 111. The remaining are 0. So 8, 16 plus 3, 19 bits are allocated for network portion. Then 4 plus 8, 12 bits are allocated for host portion. So from the IP address and the given subnet mask, we have to find the network ID. From the IP address and the given subnet mask, you have to find out the network ID. How will you find out the network ID? This is nothing but doing them AND operation, bitwise AND operation between network IP address, not an IP address and the subnet mask. So it's clearly known to us when we are multiplying a number with 1. 255 equivalent is 8 ones, no? So 8 ones are multiplied with 172 binary equivalent means you will get the same value as 172. Likewise, the next one 16. So again the thing is 255. So you are again getting 16. The next one is 1 with 224. No, you have to do the binary operation with the thing. You will get the equivalent. Okay, by merely we are doing AND operation between the IP address and subnet mask, you will get the network ID. Now, what do you mean by subnetting? Subnetting is nothing but breaking down a network into a smaller network. From that, the network bandwidth of a network can be effectively utilized. So that is subnetting. We are decomposing a network into smaller network is known as subnetting. So here the IP address classification, V4 classification, class A, class B, class C. So where class A consists of 8 bits for network and remaining 24 bits for host. Class B consists of 16 bit for network and 16 bit for host. Where class C contains 24 bits of network portion and 8 bits for host. So this is the example. From this we are given example, we are going to find out the number of hosts and number of subnets, subnet ID, network ID and broadcast ID for the example. The example IP address given here is 205.150.65.0/26. That means slash 26 means 24 bits. That is first three portion that is allocated for network. So again 24 plus 2, 26. The 2 bits are we are taking from the host portion. So we are denoting that 1 also. So totally 26. So the subnet mask will be what? 255. Then 255. 3 bits are allocated. So 255. The last one is 11. Since these three are first three 8 bit, then next one 158 bit, then 65 1 bit 24. So 24 plus 2 26. So we are taking the last 8 bit as 11. So totally 26 bits. So the subnet mask will be 11 means 128 plus 64 will give you 192. The subnet mask will be 255 plus 255 plus dot 255 dot 192. This is the for the example we are finding the subnet mask. The slash notation will give you the thing 24 plus 2. So from the last bit we are taking the 2 bit for network. The 2 bit equivalent decimal number is 192. So next. So subnet mask we found. Next is network ID. Network ID, as I said already, the network ID will be found by doing AND operation between IP address and subnet mask. So network ID also known to us. The next one, number of subnets. So for given example, how will you find the number of subnets? So in the given example, it is given as 26 already. It is 26. The 26, only 2 bits are we are taking from the last bit. So that is 2 bits. That is n. So 2 power n. 2 power 2. 2 power 2 is nothing but 4. So total number of subnets are 4. So 4 subnets are there. So number of hosts, we have the formula 2 power n minus 2. 2 power n is number of bits we are taking from host. That is 2 power 2, 2 power 4 minus 2 power host bit is 6. So out of last 8 bit we are taking for 2 bits for network. Remaining portion is 6 bits. Remaining portion is 6 bits. So 2 power 6 is what? 2 power 6 is 64. Then subnet minus 2. 64 minus 2, that is 62. So number of hosts will be 62. Number of hosts will be 62. From that we are going to find out the host ID will be from 0 to 62. That is the host ID. That is 255.150.65.0011.0012 will be the 61, 6 after 65, 61 to 62 will be the host range. Then broadcast IP is the after 62 host, the next address will be 63. 205. I'll give given as a blue line here. So 205.150.65. After 62 number of hosts 1 to 62, the 63 is the broadcast IP address. Then after that next subnet will start from the address 64. From 64 to 60 total number of 62. Then after the 62 host the address will be broadcast IP. Likewise we are giving the subnet address. So in the next session I will continue with how to find out the subnet address. In some other example, we'll go for some complex problem in the next session. Thank you all.